The 1 mm diameter shafts of 34 mm long Munce Discovery burrs are much stiffer than the 0.5 mm diameter shafts of the smallest Mueller burrs, providing greater operational control for deep exploration and troughing procedures. Discomfort had persisted despite completion of endotherapy 7 weeks prior. Off-angled radiographs showed eccentric exit of the treated MB canal, suggesting the existence of an untreated MB2 canal. Even though the initial coronal access had invaded the MB cusp, the deep target site still required further exaggeration of the mesial access wall with a high-speed tapered diamond to provide adequate visibility. 34 mm long, 1 mm shaft diameter, number 2 and number 1 Munce Discovery burrs were then used in a buccolingual sweeping motion, working into the mesial pulpal line angle, away from the furca, to remove dentin overlying the suspected yet totally hidden white line of the isthmus between the MB1 and MB2 canals. As the line was troughed, eventually it gave way to orifices at both poles, the previously treated MB1 and the untreated MB2 canal orifice. The MB2 orifice was then accentuated with the number 1/2 Munce Discovery burr. The clarification of this bifid mesial system had required exploration 7 mm beyond the floor into the mesial root. All 4 canals were cleaned, shaped, and packed by a traditional warm vertical condensation technique. This patient presented with pain associated with irreversible pulpitis in tooth number 17. Conventional access was performed and the orifice regions were refined with standard 30 mm surgical length round burrs. The prominent isthmus between the mesial canals required deeper troughing, working into the bulk of root structure in the mesial wall of both mesial canals, away from the furca, with 34 mm long Munce Discovery burrs, decreasing in burr tip diameter while progressing apically until 2 separate mesial canals were eventually confirmed 6 or 7 mm beyond the pulpal floor. While removing the pulp from the distal canal, a 2 mm segment of a number 40 Hedstrom file separated in the apical third of the canal. The radiograph demonstrates the depth of exploration in the mesial root, as well as the separated instrument in the distal. To gain unobstructed visual and physical access to the instrument fragment, a customized tapered plastic cone was first created and inserted into the distal canal to act as a visual guide and to prevent the dust of the deep exploratory operation from collecting in the depth of the canal. Beginning with the number 4 MD burr and working into the distal wall, away from the furca, the coronal to mid-root portions of the canal were expanded. Changing to a number 2 MD burr, the access was deepened and expanded further, again working away from the furca into the bulk of the distal root. After removal of the tiny remnant of the plastic cone with a Hedstrom file, the most coronal portion of the separated instrument was visible deep in the canal. The number 1 and the number 1/2 MD burrs were then used to trough around the fragment, and the dust was removed with a microtip evacuator. The radiograph shows the deep exploration within the distal root. Having gained very deep access to the obstruction without exposing the root or the supporting structures to excessive heat, an ultrasonic tip was then used to quickly dislodge the separated instrument. there it goes right there. And there it is on the margin of the rubber dam. All three canals were then projected from their deep locations within the respective roots to the occlusal surface using bonded composite around internal matrix barriers, endodontic projectors. Calcium hydroxide was placed and shortened projectors were reinserted and overlaid with cavet seals. The radiograph shows calcium hydroxide within the projected canals sealed with cavet. Now at this point we're going to skip forward. The warm vertical downpack and the backpack have both been completed. The inner surface of the composite in the projected portions of the canals was freshened with a football diamond. Any exposed natural tooth structure within the projected canals was etched and primed, and a final composite coronal seal was bonded directly over the gutta percha to the cavo surface of each of the projected canals. For this step, using a composite of greater radio opacity than that used for the buildup will produce a unique final radiographic appearance, demonstrating the canals elongated to the occlusal surface by the projection process. On polymerization, the occlusion was adjusted and the surface was polished. Through this series of clinical steps, the mesial canal system was clarified. The separated instrument in the distal was accessed with Munce Discovery Burs and successfully removed with an ultrasonic tip. The chamber floor was sealed early in treatment. Coronal fracture resistance was enhanced by an internal bonded buildup, and condensation hydraulics was enhanced by elongating the canals from the chamber floor to the occlusal surface.